If I had a 1 molar stock solution that I needed to make into a 0.2 molar stock solution with a final volume of 100 milliliters, I know that I would take 20 milliliters of my stock solution and dilute it to 100 milliliters to get this new concentration. And this is what's known as a dilution, and by the end of this video, you'll know exactly how to get this number as well. You see, this capital M stands for molarity, which is a unit used to indicate the concentration of a solution. In other words, how many moles per liter there are in that solution. And dilutions allow us to adjust the concentration of those solutions in order to make something that we need. And this is important for chemists, but also for people working in hospitals that need to dilute IV samples. The problem is that most students just want to memorize formulas like moles per liter or M₁V₁ equals M₂V₂, and they end up messing up the problem. But in this video, I'm going to show you how to do dilutions and calculate molarity with confidence. And make sure you stick around to the end because I'll give you some practice problems that should help for your next exam. Molarity is a unit of concentration, and it tells you the moles of the solute, or the thing that you're dissolving in your solution, per liters of solution. And importantly, it's always moles per liter, not milligrams, not grams per liter, not grams per deciliter. It's always moles of solute per liter of solution. So let's just start with calculating the molarity of a solution. And let's say that you're told that you have 5.00 grams of sodium chloride. And these 5 grams of sodium chloride are dissolved in 250 milliliters to make your new solution. The first thing we need to do is figure out how many moles of sodium chloride are in 5 grams. The first thing we need to do is figure out how many moles of sodium chloride we have, because remember, molarity is always in terms of moles of solute. And for that, we'll need the molar mass, because we know that we're starting with 5.00 grams of sodium chloride. If you were to calculate the molar mass of sodium chloride, you would find that for every 1 mole of sodium chloride, there are 58.44 grams of sodium chloride. And if you perform this calculation, you find that you have 0.0856 moles of sodium chloride. The next thing that I see is that my volume was given to me in milliliters, but for molarity, I need this value to be in liters. So the next step will be to convert my milliliters of solution, where I was told that I have 250 milliliters, and convert that into liters. And for that, I remember the unit conversion factor, or the fact that there are 1,000 milliliters for every 1 liter. And I can perform this calculation and see that 250 milliliters is equal to 0.250 liters of solution. And now that I have both of these values, I can just plug them into my formula, where I know that there are 0.0856 moles of NaCl in 0.250 liters of solution. And if I perform this calculation, I find that the amount of molarity that I have, or the concentration of my solution, ends up being 0.342 molar. So I can either write this as capital M, or I could write this as moles per liter. Each of these, capital M and moles per liter, are equivalent, and they indicate the molarity of a solution. Dilution is just a fancy way of saying that we're adding water to some solution to make it less concentrated. For example, if you've ever made tea or Kool-Aid that was too sweet, you could always just add more water to it to make it less sweet. By doing so, you're diluting the amount of sugar content by increasing the volume of the solution. In the same way, we can figure out how to dilute samples in chemistry. A common formula that students like to use is M₁V₁ is equal to M₂V₂. Something that often trips students up, though, is that they place the wrong M and V in the wrong places, and sometimes this means that they get errors in their calculations. So M₁ stands for the initial molarity, or the initial concentration. And V₁ stands for the amount of that stock solution that you need to use to make your diluted solution. In other words, it's the volume you take, or the volume that you're using to make your second solution. And therefore, M2 means that that is the molarity, or the concentration of your new solution. Or in other words, that's going to be your final molarity. And V2 then is going to be your final volume, or the final volume of the solution that you end up making. Now, it's a plug and chug type of formula where you just plug in the values, perform the simple algebraic manipulations, and you can get your answers. But remember to keep in mind which one you're using and use it at the appropriate time. And also, you need to make sure that your units match, because you need molarity for the capital M, and you can use milliliters or liters in the volume, but you just need to make sure that V1 and V2 are in the same units, either both milliliters or both liters. So let's take a look at how to use this equation in an example. Let's say that you want to make a 100 or 100.0 milliliter solution that is a molarity or concentration of 0.200 capital M, or molarity. And this is the solution that we're trying to make. So I'm trying to make a 100 milliliter solution that has a concentration of 0.2 molarity. If I have a stock solution that contains a concentration of 1.00 molar or 1.00 capital M, then how much volume do I need to take from this stock solution to make my new solution that's 100 milliliters at 0.2 molar? Remember that M1 is my initial concentration, and that's going to be 1.00 capital M. V1 will be what I'm trying to solve for, so I'll just leave it as V1 currently, and that needs to be equal to 0.200 capital M times 100 milliliters. So 100.0 milliliters is going to be my V2. So remember, this was M2, this was V2, this was M1, and we're solving for V1. In order to solve this, I need to divide both sides of my equation by M1, which was 1.00 molar, and for that, I can plug these values into my calculator. Notice that it will cancel out on this side and leave just V1, which means that V1 is going to be equal to 0.200 molar times 100 milliliters divided by 1.00 molar. And if I perform this calculation, I see that molarity will cancel out. 1 is the denominator, so it's just going to be 0.200 times 100 milliliters, and that is equal to 20 milliliters. And this means that I need to take 20 milliliters of my 1 molar stock solution, dilute that 20 milliliters to 100 milliliters by adding 80 milliliters of water, and that new solution is going to be 0.200 molar. Now it's your turn. Pause the video and try this problem independently, and then resume the video to check your answers. In this question, you were tasked to find how many moles of hydrochloric acid, or HCl, are in 50 milliliters of a 0.15 molar solution. We can solve this problem if we remember that molarity, which is capital M, is equal to moles of solute per liter of solution. And since molarity is in liters of solution, the first thing I should do is convert 50 milliliters into liters. And for that, I can take 50 milliliters, remembering the conversion factor that for every 1 liter of solution, there are 1,000 milliliters, and I would find that this means that I have 0.050 liters of HCl solution. And since I know that I'm starting with 0.050 liters of this solution, and I'm trying to convert this into how many moles of HCl I have, I can remember that capital M, or molarity, is just a conversion factor. Because remember, I can rewrite 0.15 molar as 0.150 moles of HCl for every 1 liter of solution, which means that I can place this as a fraction into my dimensional analysis, where I will write 0.150 moles of HCl, which is the solute, for every 1 liter of solution. And now liters will cancel out since it's both in the numerator and the denominator. And when I perform this calculation, I should end up with just moles of hydrochloric acid. And if you perform this calculation, you find that you would get a value of 0.0075 moles of hydrochloric acid. And this is an example of the type of problem that you can be expected to answer when you take a chemistry course. If you check the description, I have thousands of practice problems that you can check out to help you ace your chemistry class. Drop a comment down below if you have any questions related to chemistry, and make sure that you subscribe to the channel so that you never miss out on another video. I'll see you next time.